Today's honors geometry lesson is on section 7.6, angles inside and outside the circle. The objective is to solve problems involving angles formed by chords, secants, and tangents. Theorem 7-9 states, the measure of an angle formed by two chords that intersect inside a circle is equal to half the sum of the measures of the intercepted arcs. So let's take a look at two examples. For each figure, we're going to find x. So we know that in order to find x is going to equal 1/2 the sum of the intercepted arcs of 130 degrees plus 60 degrees. So if we go ahead and solve for x, 130 and 60 is 190, and 1/2 of 90 is 95 degrees. So we know that the angle created by two chords that intersect inside the circle with an arc of 130 and 60 is going to equal 95 degrees. So using the same formula, let's take a look at the second example. In this case, we're given that the angle created by the two chords is 62 degrees, and they want us to go ahead and find x for each arc. So if we set up the similar equation, we can say that 62 degrees is going to equal 1/2 the sum of the two arcs created. So 1/2 of 3x plus 2, which is one of the arcs, plus x, which is the second arc. So if we start solving our equation, 62 is going to equal 1/2 4x plus 2. So remember, to get rid of the 1/2, we're going to multiply both sides by the reciprocal, which is 2. So we have 124 is going to equal 4x plus 2. And then from here, we can just solve our two-step equation. So subtract 2 from both sides. So we now know that 122 is going to equal 4x. And when we divide both sides by 4, we're going to get a value of x that is equal to 30.5. Theorem 7-10 deals with angles that are created outside the circle. So this theorem states the measure of an angle formed by two secants, two tangents, or a secant and a tangent drawn from a point outside a circle is equal to half the difference of the measures of the intercepted arcs. So for the next three slides, I went ahead and gave you an example of each. So let's take a look at an angle created by two secants that intersect outside the circle. So here we have angle 1. So to find angle 1, we're going to take 1/2 the difference of the measures of the intercepted arc. So in this case, the measure of angle 1 is going to equal 1/2 times the quantity of x minus y. And we want to make sure that we always take the largest arc created and subtract the smallest arc created from that number. If we look at a second example of the same theorem, this is an angle that also is created outside the circle, but this time, instead of two secants, it's created by two tangents. But you're going to notice that the formula is very similar. So to find the measure of angle 2, we're also going to take 1/2 times the quantity of x minus y. So 1/2 times the quantity of the largest arc minus the smallest arc. And the last figure we're going to look at is an angle that is created by a secant and a tangent that intersects outside the circle. So we're going to call this angle 3. So the measure of angle 3 is going to equal 1/2 the quantity of x minus y, or 1/2 times the quantity of the largest arc minus the smallest arc. So let's go ahead and take a look at three different examples with angles created outside the circle, one with two secants, one with two tangents, and one with a secant and a tangent. So for the first example, we're given that the measure of angle x is 30 degrees, and the arc measure of z is 86 degrees. So before we do anything, let's go ahead and come up with a formula. So if we want to find x, we know x is going to equal 1/2 the difference of the largest arc minus the smallest arc, so z minus y. So then from here, we can just go ahead and fill in the information that we have. So we know x equals 30 degrees. We know that z equals 86 degrees, and we're trying to find y. So if we start solving our equation, we can multiply both sides by the reciprocal of 1/2, which is 2. So 2 times 30 is 60. So 60 is going to equal 86 minus y. And if we subtract 86 from both sides, we're going to get negative 26 is equal to y. So now we know that y is going to equal 26 degrees. So for the second example, we're going to do something very similar. So let's label what we have. This time we know that y is 70 degrees and that z is 180 degrees. So using our variables, let's set up an equation. So we know that the angle measure of x is going to equal 1/2 the sum of z minus y. So again, we want to take the largest arc and subtract the smallest arc. So if we fill in the information we have, we know that x is going to equal 1/2 180 minus 70. So 180 minus 70 is 110. So x is going to equal 1/2 of 110. And then half of 110 is going to give us a value of 55 degrees. So now we know that the angle measure for x is 55 degrees. So let's take a look at the last example, which is an angle formed by two tangents that's outside the circle. So in this case, the only information that they've given us is the value for y, which is 100 degrees. So if we use what we know about circles, we know that a circle contains 360 degrees. So if y is 100, z must be the remainder of that. So if we take 360 minus 100, we actually know that the value for z is going to be 260. So then from here, we can go ahead and set up our equation based on the variables we're given. So in this case, x is going to equal 1/2 z minus y. So x should equal 1/2 260 minus 100. So 260 minus 100 is 160. And then 1/2 times 160 gives us an angle measure of 80 degrees. So we know that the angle of x is going to equal 80 degrees. So this is the end of the lesson. If you have any questions, watch the video for a second time. And after watching that video, if you still have any questions, write down those questions and bring them to the next class.